Welcome to my YouTube channel Educational Academy. Myself SRINIVAS ARUKONDA. If you are visiting first time to my YouTube channel, kindly subscribe it. Now we are going to see the basics of theory of automata. So if you are learning some language, means you should know the basics. If you are learning your own mother tongue, if any of the language, means you should know the basics. So here theory of automata also, the basic knowledge is required. All the basics, if you are so very clear, then all the in future classes it is very easy to understand. Just see the basics. So in the theory of automata, the basic thing is symbol. Symbol is one of the basic block of the theory of automata. The symbol is you are representing is anything, either it may be the letters, alphabets, A, B, C, any of the thing, or you may write it as a numbers, either 1, 2, 3, anything. Look, any specific symbol you can represent in the theory of automata. That is the basic building block of the theory of automata. That is the first thing you should know, a symbol. From the symbol only you are able to define the remaining things. So after the symbol you should know the alphabet. So what is alphabet? So in English language you know what is alphabets. So alphabets you are representing. For example, if you are learning English, means you should know the alphabets. You know the alphabets, right? A to Z. Like in theory of automata also we are going to define the alphabet. The alphabet is you are going to use the different set of symbols you are going to use in the alphabet, right? For example, here see this alphabet you are representing with this sigma. Notation is alphabet notation is sigma. Either it may be 0, 1. It means in this alphabet only you are going to consider 0 and 1. The two symbols only you are going to consider here. And this is also one more alphabet you are representing. That is a set of all lowercase letters. So that is also one type of alphabet here. Otherwise, the set of ASCII characters. You know all the different ASCII characters, right? So all the set of ASCII characters also you may use as the alphabet in theory of automata. And if you understand, now you understood what is the basic building block. That is the one is a symbol. So from the symbol you define the alphabet. Now from the alphabet you are in a position to define the string. Similarly, English language also you learn like that, right? First you learn the normal symbols. If you know the A, after that B, and all these sequence you are calling it as alphabet. Then from this alphabet you define the string. String is simple here. So string is just for the sequence of the symbols. If you are taking the sequence, like for example A, using the A, what are the different patterns as possible? Sequence A, like this. For example, AB combinations, AB, AAB, ABAB. So different patterns are possible. So here the definition of this string is sequence of symbols. You are giving as a definition of a string in this theory of automata. The string, sometimes you are calling it as a word. It is a finite sequence of symbols chosen from the alphabet. So finite, if you are able to take any of the finite sequence of symbols. For example, I am taking one example here. The sigma 0, 1. I am taking as alphabet as a 0, 1. You can take either any alphabets like A, B, C, D also. But here I am taking the 0, 1. So from the 0, 1, what are the different sequences are possible? So one sequence is possible here. 0, 1, 1, 0, 1. So any of the different random sequences are possible. I am taking this is one of the sequence. So this particular sequence you are calling as a string. This is the string. It is generated from the alphabet 0, 1. And if you are defined the string, and one more you should know the empty string. So sometime in the theory of automata there is a possibility of the empty string. It means if you are defined the string, that is a sequence of symbols, right? There is no symbols. Still you are calling it as a empty string. In empty string, you are defining as empty string is simply it is a string, but there is no occurrence as a symbol. There is no symbols, there is no possibility of a symbol. You are calling it as an empty string. So you should know this symbol. From the symbol you define alphabet. From the alphabet you define string. Now we are going to see what is the length of the string. For example, you already defined a string. You are going to find out what is the length of the string. For example, the string is defined here 0, 1, 1, 0, 1. This is the string. You are taking this string from the set of alphabets 0, 1. From the 0, 1, many number of the strings are possible, but I am taking the 0, 1, 1, 0, 1. This is the one string. So I want to find out the length of the string. The length of the string is very simple. Just you have to count number of positions. So 1, 2, 3, 4, 5. Total 5 positions are there. The length should be 5. So like that you can compute very easily the length of the string. Next, one more is there, power of alphabet. How to compute the power of alphabet? You know the alphabet, and what is the power of alphabet? Power of the alphabet you can represent it is sigma power k. So sigma you already know, that is the set of alphabet. The alphabet you are representing in terms of a sigma, and the k is just basically you have to understand here k is the length of a string. So how much length you are going to define? The k is length. So here the set of strings of length k. So you are going to generate all the different type of strings, the length k. K is any value, right? I am taking here example, sigma is a comma b, and from the a comma b you are going to define, for example, sigma for 0, it means the power of this alphabet is 0, means the 0 length. 0 length strings I am going to generate from the alphabet a comma b. So the 0 length is, it means there is no need to consider, that should be empty string, that you may represent, you already know what is empty string, you are representing in the epsilon. And one is sigma for 1, it means all possible strings length 1 from the input alphabet a comma b. So only length 1 is either a or b, that is the length 1. Next, like that length 2 also possible, because a and b is there, all the different possibilities AA, AB, BA, BB. These are all comes under the length 2 alphabet. It means the sigma for k, the k value should be 2. The 2 is nothing but here the length of the string should be 2. Let's see here sigma star. Just now we discussed the power of the string. If the power it may be the star. The sigma star, the meaning of the sigma star is set of all possible strings over sigma. So what are the all possible strings? Including the empty string. Including the empty string, what are the all possibilities? Right? Infinite number of strings are possible with any specific. Sigma should be the 0 and 1. So from the 0 and 1, what are the possible strings you are going to generate? What are the different possible combinations? Including the star. Whenever the star is coming, it means definitely the empty symbol also you have to include. Empty string you are going to include in your complete set. First one is epsilon. It means 0 occurrences of symbol. There is no occurrences. It may be the length 0. Next is the length 1. So with the length 1 is either 0 or 1. And next is length 2. Length 2 is all the length 2 strings generated from this alphabet. Either 0, 0, 1, 1, 1, 0, any of the possibilities. And after that length 2 over length 3, length 4, like that infinite number of strings are possible over this alphabet. So the sigma star, whenever the star is coming, you have to remember, including the empty string, all the sequence of all the set of strings are possible. So you have to consider all the set of strings. Next, the sigma star you can represent like this also. The sigma star is nothing but it is, if you are taking consideration of the empty string along with this sigma plus. Sigma plus is nothing but excluding the empty string. Excluding the empty string, if you are combining, you are adding this empty string also, it means this is the all possible strings are there. This particular thing you are representing in the sigma star. And one more representation is the sigma plus. Sigma plus is nothing but you are not going to count the empty string. Except empty string, all the remainings, what are the possible things are there is nothing but all the remaining powers, except you have to remove the 0 power. So sigma for 1 union sigma for 2 union sigma for n. So all these union you are going to get the sigma plus. Yeah. Next important thing is the language. We already seen what is the basic building block, the symbol. Then after that we seen different alphabets. Then using that alphabet you define what is string. From the string you are going to define the language, right? Just see the definition of a language. In theory of automata, you are able to define the language. A set of strings, all of which are chosen from some sigma star, where sigma is a particular alphabet is called a language. So basically the language you are going to define, that is set of strings. The set of strings you are taking from some sigma star. What is the sigma here? Sigma is any particular alphabet. It may be either 0, 1 or A, B, anything, whatever the input alphabet you are taking. From that alphabet you are able to generate the all possible sequence of strings. So all those strings are defined from the sigma star. You are calling this particular representation, all those set of strings, you are calling it as a language. And if sigma is in any alphabet, the language L is always subset or equal to sigma star. It means the language may be equal to the set of all possible infinite language. If it is infinite language, and the two, if it is equivalent to the sigma star, or it may be subset. It means what are the languages you are taking in the theory of automata, all the languages you are taking from the sigma star. If you are defining a language, means the definitely subset of the sigma star. L is subset of or equal to sigma star is nothing but whatever the language you are going to define in the theory of automata, although languages are subset of the sigma star. Sigma star is that is infinite language, it consists of all the possible strings. Here, just see here, just now I define the language definition in the theory of automata. So I am giving the two different examples based on the definition. See here, the first one, the language of all strings consisting of number of n zeros followed by n ones. So this is set of strings you are going to generate. The number of zeros and number of ones are n. It means 0 number of zeros and 0 number of ones, 1 number of zeros and 1 number of ones, 2 number of zeros and 2 number of ones, 2 number of zeros followed by 2 number of ones. So this is the representation sigma. It means 0 zeros followed by 0 ones, and 1 0 followed by 1 1, 2 zeros followed by 2 ones, 3 zeros followed by 3 ones, like that, so on. It is infinite language. This language is if you are writing like this, that may be infinite number of strings are possible. Similarly, one more language is there, the set of strings of zeros and ones with an equal number of each. So you are going to represent number of zeros and ones, those are equal number. Either it is there is no proper which one will come first, which one will come last, they are not given in this language. The number of zeros and ones should be equal, that may be any order. Like first is empty, 0 and 1, it means 0 and 1 is coming, 0 first, 1 second, the next one is 1 0, 0 0 1 1. So here 4 possibilities are possible. Like that you can continue. This is the second type of language. Just now we seen the language definition as well as the different examples of the languages. But here one more way also you can represent the language in theory of automata, that you are calling is a set former notation. Set former, always you have to represent the language in this curly braces. So here you are representing W such that this is the notation for the backslash. It is nothing but the subject W such that something about the W. You have to write what is the W, what exactly this W is, the word or set of strings. This word, what exactly this word is giving the information. I am giving the 3 examples of this set former notations. The first example is W. This particular word W is giving information about the language. What is this particular W? It consisting of an equal number of zeros and ones. This is the one of the example. And second representation is W. W is a word. The W is a binary integer, that is a prime. You are going to generate all the sequence of strings, that is prime number. That the sequence of the string that should represent the prime. And the third is W is a word. W is a syntactically correct C programs. Syntactically correct C programs. What is the meaning of this syntactically correct C program? Because the C programs are infinite number of C programs are possible, but syntactically valid C programs only we are going to consider here. That is the set. That is set of strings you are going to generate. Those are syntactically correct C programs. So you can represent the language in theoretically. Just before this we discussed the language representation. That is, for example, a language L it consists of n number of zeros followed by n number of ones. That is one representation. So here the set form of notation also you can represent the language. So always you have to give the information about the W. W is a word here. The word and what exactly this word is giving information. That is the set of strings are going to generate in that particular language. These are the three different examples of the set form notation.